those of you who may not know, we've archived our past webinars on our website. It's www.uesystems.com, where we've covered a number of topics, including bearing inspection, testing steam traps and valves, diagnosing electrical emissions, and prevention of arc flash. And I invite you to visit them when you can. Today, Mike is going to be speaking about documenting a fast return on investment and how we can reduce our carbon emissions and find other opportunities from an ultrasonic compressed air survey. For those of you that don't know Mike, he's one of our leading instructors in UE Systems Training Division. He has several years of hands-on field experience with ultrasound technology. His knowledge plus his experience, I'm sure, will give us a great learning experience today. Okay, Mike, it's all yours.
Thank you, Alan. Today we're going to talk about compressed air. I hope this is a relaxed webinar for you guys. I'm kind of lax about the way I talk, so if you couldn't figure that out. But let's talk about UE Systems real quick. What we do, number one, is we manufacture ultrasonic equipment. Once we do manufacture that and you purchase that from us, we train you and we try to keep you up to date with all the information that we can. UE was founded in 1973. We have 35-plus years experience in ultrasound, and we make up a very large global footprint. We really are out there. With 12 direct regional offices in the U.S., Canada, and Mexico. We have international support offices in Latin America, Europe, and Asia. And that gives us well over 200 independent distributors worldwide. So you can get a hold of us just about any way you can think of. Now, while we're here, number one, I suppose that you have a reason for joining in this webinar. And why check for leaks, though? What is your reason behind this? The importance can vary depending on who you are and how you view this. But economics, we're here to save money. Compressors eat a lot of electricity. I think we all know this. You're running a compressor that is inefficient to begin with, and we're going to talk about that later, but it's feeding leaks. So if we plug those leaks, maybe we can save some money there. How many times have you heard, we bolted on another compressor, we've been losing pressure, but no one went out and looked for leaks, they just bolted on a whole new, expensive compressor just to up that pressure. All right, environment, toxic, harmful gases escaping to the atmosphere. That's no good. Plus, what we're kind of talking about today, carbon emissions. You have to think about that compressor may very well be running on electricity, and more than likely is. What are we emitting into the atmosphere as carbon dioxide from the power plants to make that electricity that you're buying to feed the compressor that's feeding the leaks? Safety, not a real big thing here as far as what to talk about. I think you get it. Again, it's toxic. It could be explosive gases we're looking for. And then, of course, weakened pipes and vessels. So safety, a big issue, but I'm not going to go deep into it. I think you can figure that one out for yourself. And then quality. Is compressed air used in the production of your end product? We need to be sure of the correct pressure and the quality of the air that it's delivering. So just a few reasons we might be checking for leaks. Everybody is scrambling in the industrial and commercial world right now. It affects us all. We're seeing cutbacks in spending on travel, purchases, even on maintenance. Even loss of jobs are occurring. I know I hear it everywhere I'm going right now. We've lost guys. We're having to do more with less. It's been going on for a long time, but it's really hitting everybody right now. Even at home, we personally cut back on traveling because of gas prices. We saw them skyrocket last summer. They kind of went down, but now they're rising again. So we really, it's affecting every one of us. This leads to an economic approach which calls upon industrial and commercial institutions to find new and unique ways of improving their bottom line, to the point of changing lights to fluorescent lights from incandescent, putting motion sensors in just to save on electricity. Everyone's trying to save on that bottom line. How are we going to save money to make it? Economic strains are made worse by regulations on emissions into the air, water, and the ground. This costs money, such as installing scrubbers, monitoring the chemicals that are going into wastewater, so on and so forth. So, we're being monitored. We have to make sure what we're putting out there is okay, but that costs money to do that. And now in Europe, there's an effort to reduce carbon emissions through regulation and carbon trading. This is kind of a new thought. We're going to talk about that. That thought is flowing over to Asia and to the Americas. Canada is seeing the development of carbon trading, and some regions in the U.S. are also embarking on carbon trading. In Chicago, there's actually an exchange dedicated to carbon trading. So let's read. What is carbon trading? It is a system of emission credits that allows a company or country that reduces its carbon dioxide emissions below a target level to sell the extra reduction as a credit to a company or a country that has not met that target level. So basically, you're going to be told, or you're going to purchase, how many credits that you can emit carbon dioxide. If you emit more than that, then you'll have to buy more credits. If you emit less than that, then you'll be able to sell that on the stock market. So basically, we want to get ahead of that game before it starts. Carbon trading, when implemented universally, can offer new opportunities for revenues for those who keep records of their emissions and comply with regulations. We're going to give you a way to start doing that now. You won't use necessarily our software to prove what you've done, but if you've already started cutting back on your electrical use, then you're ahead of the game. Fossil fuels are depleting, and we are trying to find new energy efficiency. And because of that, our dependence on fossil fuels and the lack of them, prices are higher as they are becoming harder to find. I think we all realize that. And really going back to the pump, it's really affecting us all. To reduce the impact of finance for the fuels, companies are aggressively finding and implementing new programs to reduce the usage of energy. Some of the programs require a lot of money to initiate. It may take years to complete them. But today, we are going to talk about ultrasonic compressed air leak detection. And with that, we're going to talk about the method that can reduce energy use and carbon emissions at the same time and offer an almost immediate return on investment. And again, that's going to be leak detection. So let's get going on that. So why is compressed air so inefficient? Let's look at that pie chart for a second there. Number one is the whole pie itself, the whole circle, that's 100% input of energy. And out of that, what we get when we get the compressed air on the other end, only 18% of that is usable out of that 100% we put in. Now this could vary depending on the compressors. I realize people have reciprocating or rotary screw vane or centrifugal, maybe multi-stage compressors or something of that, you know, and that makes that a little different. But let's say we even double that usable energy to 36% efficiency. Is that a good standard? I don't really think it is. So really, what we're doing is we have an inefficient machine feeding leaks, making it more inefficient. So we want to get the very most efficiency out of that machine that we can because it's already inefficient. And just to give you an idea, I looked up some stuff here. On average, 8 horsepower of electricity, it takes 8 horsepower of electricity to make 1 horsepower of compressed air. That's not a very good ratio. 1 horsepower of electricity on average is about 746 watts, or you can think of it as 1 horsepower of electricity will produce about 4 CFM. So a lot of electricity just to make that compressed air, right? So we really want to make that as efficient as we can. Now, how do ultrasonic instruments work? I told you we're going to be able to detect the compressed air leaks. And let's talk about that for a second. I'll read that and then we'll talk about it. Ultrasonic instruments detect the high-frequency turbulence created by any compressed air or gas leak. It is not gas-dependent. What's happening is this. Imagine a pipe with compressed gas in it, whether it's air or gas, it doesn't matter. And imagine that pipe springs a leak in it. And so you have that compressed gas escaping out into atmosphere, which will be a lower pressure. What happens at that leak source? That gas, that compressed gas, wants to expand out to the lower pressure outside. Once it does that, or as it's doing that, it forms little vortex and eddies, or think of them as tornadoes. And all that, what we call that, right in that area, that leak site, is turbulent, or turbulent air. Turbulence emits ultrasonic sound waves. Ultrasonic sound waves are very directional, which allows us to find them very easily with the instruments. All right? So with the high-frequency sound waves, we hear them easily. You may be thinking, how can I hear this in a noisy environment? Number one, we must think just because it's noisy to our ears and our audible range does not mean that it's going to be noisy to our ultrasonic unit. Remember, we're going to focus in on a certain frequency. For air leaks, it's 40 kilohertz. And at 40 kilohertz, it may not be very noisy or as noisy as you thought it was. But let's say that it is very noisy in the ultrasonic area. Remember, the sound is very directional, so that signal is very directional. So we can key in on one sound and follow it to the very source of it. All right? These sounds are then heard through the headphones, and the amplitude is measured in decibels or decibels, and we abbreviate that dBs. So what I want to talk about right now is how do we locate that leak? And I'm going to go through this fairly quickly, but just to give you an idea, let's look at that picture on the top left-hand corner is the #1 picture there, and that's called gross define. That is the method. The gross define method is how we find air leaks. So what that means basically is we're going to start out with a big area, and we're going to narrow it down till we pinpoint that leak at the very end. So at the very beginning, we see that gentleman starting at a distance from the area that he is scanning, and he has his sensitivity turned all the way up. And think of sensitivity as how much power are you giving that unit to listen to that sound. So if we turn that power all the way up, or the sensitivity all the way up, we're hearing all kinds of stuff. And right now, he's probably hearing everything, so he can't hear it all that well, so he'll adjust the sensitivity down until he finds a directional sound wave. Once he finds that sound wave, he's going to adjust it down to just where he can hear it. It doesn't need to be loud. Loud is not always good. And he keys in on it, and he's going to start walking toward that sound. He should have adjusted it down to the point that he hears it when he's focused straight on and he's listening, and he flicks his wrist to the left or to the right, that he barely hears it in either direction, or doesn't hear it at all. But when he comes back to the center where he heard that sound, he should hear it nice and clear. And then he'll start walking toward it. As he walks toward it, he's going to scan in all directions. Think of it as northeast, southwest, up, down, side to side. But he's going to scan in all directions as he keeps moving forward to make sure that he keeps his bead on that line of sound, line of sight, line of sound. All right? So he's going to keep going. He's going to constantly, though, be adjusting his sensitivity. As you look in picture #2, as he gets closer to that equipment, he's going to be picking up more competing ultrasound, other ultrasounds in the area. So he will have to adjust that sensitivity down to maintain that line of sound. In step #3 on the bottom here, we see that he's put a rubber focusing probe. You can just barely see it there. Let me highlight that. And right here, he has the rubber focusing probe on the end of the boot, all right, or the boot on the end of the gun there. What he's done, what that does is that allows him to focus in just on that sound. Narrows his field of view dramatically, so he's just listening to the sound directly in front of him. So it's shielding out competing ultrasounds, narrowing in his field of view, and he puts that rubber boot on, the rubber focusing probe, when he gets in with about 2 to 3 feet of that search area. It doesn't kill your distance, but it's definitely going to narrow that field of view. So you don't want to be at a big distance and narrow your field of view too early. All right, so once he gets to that suspected leak site, he sees all that piping, he knows that leak's in there somewhere, he's going to put that rubber boot on there. All right, and in step #4, once he detects it, once he gets up close, he's probably going to be hearing it here and there, but when he comes across it, he's going to hear it nice and loud, and he's going to take that boot, and he's going to seal up on that pipe right there, and he's either going to hear it or he's not going to hear it. If he still hears it and it's nice and crisp and loud, he knows he has that leak. If he say he's sealing up over here somewhere where the leak is not present, he will not hear that leak. But here, he'll hear that leak nice and loud and clear. So sealing up on the leak site is the way we confirm that there is a leak there. Okay, so I know that was quick. We will continue on here to the next slide. All right, once he's sealed up on that rubber boot or on that leak site with the rubber, he's going to store the decibel. But before he stores the decibel, once he's up here in this area, he's going to back off 12 to 15 inches from where he's sealed up and where he located that leak. and where he confirmed where it was. He's going to back up 12 to 15 inches or 30 to 38 centimeters there, and then he will store the reading. So remember, confirm where the leak is, then from that point, from that leak site, back off 12 to 15 inches directly, and then store the information. Once we store it, it's going to store the information as a decibel right there. Excuse my drawing. But we're going to measure the leak in dBs or decibels. That decibel is going to give us a whole lot of information. Also note that he is at 40 kilohertz. All right, and that is the place to be for air leaks. Now when you store the information, you're either going to store it if you're using the 10,000 on a compact flash card, or if you're using the UltraProbe 3000 or 9000 on the onboard memory. And then you're going to connect up to the computer and download the information, whether it's on the flash card and you have a flash card reader, or you connect directly to the gun with the 3 or the 9000. You're going to download that information. And once we do that, we're going to be able to calculate cost, calculate greenhouse gas emissions, and how we're avoiding that as well. Okay? And so the software is going to give us a whole lot of information. With that thought, let's look at that software. This is just a clip, just a little bit of a screenshot out of some of the software, which we are definitely going to go into. But here we see, right here, we see the year-to-date is $56,000 identified, $56,000 worth of identified leaks. All right, and that's the year-to-date. If you notice, the software will actually keep up with every survey you do. So we have the month of June at around 9,000, July around 19,000, and August around 26,000, and then tallied for a whole of $56,227.99. If we move over here to the repaired leak cost avoidance, it's actually giving us how much, once we repair it and document that, it's telling us how much we've avoided in an electrical cost. It also gives us a percentage of what we've completed as well. Also, it gives us our CFM. What are we leaking in CFM? Cubic feet per minute here, all right, per, and it'll give us a tally of overall as well. But we can convert that CFM into kilowatt hours, and once we do that, we can get a cost, and we have our cost here. So it's doing it automatically for you by you just putting the decibel and the correct pressure in there that you were scanning for. So we will move forward. The big thing that the software also does for you is we've been talking about the carbon footprint or the carbon dioxide avoidance and stuff like that, is this allows us to see what we're avoiding in that carbon footprint by not using that electricity that we were using. We show it in pounds, but it shows us carbon dioxide in pounds here, the identified and the realized, meaning the completed repairs, what we've avoided, the nitrogen oxide here, the identified, and then the completed as well, and then sulfur dioxide. So it's given us a way or an idea of what we're actually avoiding. It's giving us a number, a figure, which really helps other than just plugging the leak, which of course is the most important part, is we're going to correct these leaks once we have identified them, but it's letting us know, hey, here's what we were leaking, here's what it was costing us, here's what we were putting out into the atmosphere, now look at what we're not putting out into the atmosphere, look at the money we're saving. Okay? So now, let's see how we convert all the data collected from the compressed air survey into usable, reportable data. So what I'm going to do is we're going to back out of the PowerPoint presentation right now, and we're going to look at the software itself. So we'll start with UltraTrend DMS. So I'll give that time. I know it takes a little bit of time for y'all to catch up from my screen, so I'll make sure that it's up there. Hopefully everybody is seeing UltraTrend DMS version 3. And now I have a plant opened. Well, I don't have it opened. I have it highlighted there. And that Maple Street plant comes in every version of DMS that we give to you as an example plant. So you can follow along with yours. You can go back and do what I just did to the T, because this is the same plant that you should have in your software. So Maple Street's the name of the plant. And of course, for DMS, I'm not going to go through all of DMS right now. We have webinars previously done that will walk you through, just like I'm doing, through the DMS, how to upload, how to download, and everything else. Do remember, though, when we are uploading and downloading to DMS, it's very important to go to Communications and know what you're doing. Remember, send group to flash card, download from flash card is for the 10,000 only. upload group and download group is for the 3000 and the 9000. More than likely, for the 3 or the 9000, you'll probably have to configure that port because you are on a cable. And once you configure it, you test it, and it's either going to say unsuccessful or successful. If you're successful, go on with your upload and download. For the flash cards, it's a matter of just plugging in the flash card reader to your computer, sticking the flash card in there, and following the instructions as you do it. All right. If you're confused about upload or download, think of the unit above the computer. You're going to upload to the unit or download from the unit. All right. So just hold the gun up above the computer, and you know you're uploading to it or downloading from it. As far as send group to flash card and download from flash card, send group means we're going to load a route to the flash card. Download means we're taking that route and the information we collected off the flash card. Okay, so let's get back to here. So Maple Street is part of the hierarchy. It's the first level of the hierarchy, and I'm going to open that. And we see that we have many applications that we allow you to create routes, or what we call groups, for. What I'm concerned with today is the application of leak. So I'm going to open up leak here, and you can have many groups and many routes under each application. Okay. Right now we only have one group or route, utility. That's the name of the route. So we've broken it down, Maple Street to leak to utility. And once I open up utility, it's going to actually load that route. Realize that we have not loaded information until this point. It makes it a little faster for most people, apparently not me, to load that information. All right, now, here I have the route, and these were collected data points. You don't necessarily build a route for air leaks. You may build it down to Maple Street leak and then name the area that you're going to go survey, but how in the world would you know to the exact point you would find those leaks? So the way this one was particularly done was they built it down to utility. They're going to go survey the shop. All right. Once they surveyed it, they added all this in when they downloaded the information. This was blank, but when they came back and downloaded it, it populated it for them. So the shop area, they used tags for each one of these that they located. Each one of these numbers is an identified leak. The tag number for this first one here is 12334. Notice it has a 001 after it, and if you go below that, notice it has a 002 after it. And then so on and so forth all the way down. The computer will automatically generate these numbers here, the 001, the 002, and 003. Don't be concerned with those. Those are your point numbers or your location where you exactly found that leak. The way you're going to keep up with it is either by description or by the tag number, a 2- or 3-part tag that you can get from us or wherever. But you want to tag. You know, how is anyone going to come behind you and literally know where that leak was to repair it? But 12334 was that tag number. And let's open up that tag or that find, and we keep up with the readings by time and date. So we have 7/9/2008 was when it was found at 2:02 p.m. Notice when I highlighted that reading there, it highlighted or activated the field view over here. Okay, so let's walk through real quick and talk about this. Number one, we have the time and the date here. And it's done in military time, but the date is, month, day, year. We also, the most important thing we are collecting while we're out there is here, the decibel. Now, we need the time and the date, too, to make a good report. And we want to see the frequency to know that we were at 40 kilohertz. But that's reporting all that information back to me. The other thing that is so important to make sure that you gather the information on is, of course, where was the leak, but what was the pressure? Do you know what the pressure was at that point? Are you running on a 100 psi system, but you're all the way across the plant? Do you think it's really 100 psi, or should you estimate it down maybe a little lower to 75 psi? Is there some kind of gauge on the other end where you actually know what that pressure is at that point? So don't, just because the compressor says it's putting out 100 psi, by the other end of it, it's probably not getting 100 psi. So you might want to check that any way you can. All right, but again, these are the big important things, dB and pressure. Those two things are going to give me a CFM, and we need that CFM dramatically. And then again, we double check our frequency for 40 kilohertz, and of course, it'll populate the date for us. All right, the rest of it, we don't really need that information other than maybe down here at comments. Comments, we could type in here, notice I wrote in found at joint 1 and line 5. This will export this information as well. Okay? So with that, let's look at the next one. Let me go back over here and change out that highlighter just so you get the idea. If we look at this one, we'll open up that reading, and we see 40 decibels here at 150 psi here. Do you see that? So all the information can be changed in here. You could change that to 100 psi if it was 100 psi or whatever the pressure was, or just leave it where it defaults and then export it, and then change it in the compressed air software. So let's say we're done here. Let's say we've downloaded this information. We've come in here to check, and we've made sure every one of these has the correct, the readings for us, the decibel. Maybe we've added some comments as a description of where the leak is located, and we made sure where the pressure is. All right. Once we get to that point, what we want to do, I'll close this up to make this look a little neater. We want to go back up to the utility, the name of the group is what we want to do. We want to export all that information we just collected into the compressed air software. Now, we have just recently updated this and put the compressed air software into DMS, so you can export straight to it, whereas before you had to manually input all the information. If you still want to do that, it's still available on the web. You can keep on doing it that way. But let's go through here, and I'm going to show you what we've done different and made it a little easier. So I've highlighted. Notice you've got to highlight the name of that group, the name of that route. We call it a group to be able to export. Once I do that, notice there are tabs here at the top. We were in the Field tab. We're going to skip the history info, the chart, and the images, and we're going to go straight to Report tab. So I'm going to click on the Reports tab. Once I'm in the Reports tab, I have two options: View Group in Excel on the bottom, Launch Export Wizard on the top. Forget the View Group in Excel. Remember Launch Export Wizard, all right, because it's going to walk us through exactly what we want to do. So I'm going to launch that now. So here it just tells us what it's getting ready to do. You can read through that when you do it. Just go ahead and hit Next, and it's going to give me my options. We have 4 options in here for you. We have Simple Mode, we have Advanced Mode, we have Quick Mode, and those are for exporting stuff like a bearing group or route and stuff like that. What we want to do is the compressed gas spreadsheet, and that's right here. That's what we're going to choose, the compressed gas spreadsheet. And I'll get back to the being able to choose that. I'm going to select that by clicking in the circle, and that gives me the green dot in the circle. Now I know I've selected that. And now once I've selected it, I'm going to hit Next. Everything is set up for you. All you have to do is decide where do you want to put it. I have a folder waiting on that on my desktop just for that, if I can find it. There it is, Air Survey. And I'm going to export that straight in there. And that's all you have to do. You don't have to do anything else. You don't have to tell it what to export. It's all set up for you. And we'll wait. My computer is slow. Maybe that's helpful for you guys, as there's a bit of a lag time, I believe, as you're trying to see this. So it says export is complete. You have successfully completed the data export wizard. It shows us where it exported it to. We don't have to save this query because it's already saved for us. It's always there for us. And then to close this out, we're going to hit Finish. Now what I'm going to do is go into that air survey. I'm going to shrink down DMS because we don't need it anymore. And we'll shrink that out of the background there. And I see that I have Maple Street Leak Utility sitting in my folder that I exported it to, and it's an Excel spreadsheet. Just a quick note on that, you'll need 2003 or higher for Excel for this to work properly. It'll fight it if it's not 2003 or higher. Okay, so let's click on that and get this up and running. All right, here it is. Number one, what it opens up into immediately, the first thing it opens to is the exact readings that we just took. It doesn't go to the cost and the reporting and all this other stuff. We want to look at these readings first. Okay. What I'll note first is, remember we were talking about pressure in the DMS file. Notice here I have 100 here, and on the second one's 150. It also gives you the availability. You'll have to round to the lower. Don't ever round to the higher. Always round to the lower. It makes a better report. We don't want to overestimate anything. Remember, we're still estimating. There are a lot of a lot of variables in this that cause us to call it an estimate. We never want to overestimate, okay? So always go to the lower pressure, but you can change every one of those pressures right here probably quicker than you can in DMS. However, don't forget, DMS will keep those records for you forever until you delete them. So you may want to go ahead and change them over there, but it exports whatever was in DMS straight over here. Notice it has the types of gas here. All right, we're doing air. And remember, I put that note in there, found at joint 1 in line 5. So you could type in the location of it or the description back in DMS, and it will export it straight to here. Notice that one air leak at 53 decibels at 100 psi is costing $629 a year, 3.6 CFM. We'll get back to this and we'll walk through this. But first, what we need to do to make sure all of our money information, CFM information is correct, we need to come to the tab on the bottom of the screen here, Cost. See my hand down there? It says Cost. And we're going to click on that Cost tab. All right. On the Cost tab, what you need to know is what you're paying per kilowatt hour at your plant, not at your home, but at your plant or the plant you're surveying. You need to know that information. Is it 10 cents per kilowatt hour? Is it 6 cents? Or like up in the state of New York, above 20 cents per kilowatt hour? And then, of course, what year is it? And what state? We're going to talk about why we choose what state here in a minute. But we want to get the correct kilowatt hour in there. And we'll say 10 cents, or let's say we'll change it to 15 cents, just kind of in between everybody. And that's all you have to do. All right. And also, notice it says down here, operational times, down here in this box. We want to know how long is that compressor running, not how often the plant is in operation. Does that compressor ever get shut off, or does it run 24/7, 365 days a year? I'll assume this one does, and we'll leave it at hours per day as 24, days per year as 365. If not, find out what it is and put the correct numbers in there. Now notice we have air, and when I change the 15 cents per kilowatt hour up here, the air cost changed to 0.49 or 49 cents per 1,000 cubic feet. All right, and so whatever you put in here will directly affect what that 1,000 cubic feet is. Notice we also have some other gases here: argon, helium, hydrogen, nitrogen. Maybe you have some other kind of gas you're buying. To change what's in there, simply click in that box, come to Tools, Protection, unprotect the worksheet, and change the name of it, and then come back immediately and re-protect the worksheet under Tools and Protection. Protect everything when you re-protect it. All right, so we don't want to mess up any of the macros or anything like that in here, the equations. But once you do get the correct name, say we are going to scan for argon. Let's say it's $25. We'll click in the box, and we'll change that to $25 per 1,000 cubic feet. I actually have no clue what argon would cost, and of course it would vary on who you're getting it from and where you are in the world. But let's say it's $25 per 1,000 cubic feet. So now, once we've got everything set up in here, wait, one thing more. The most important thing I almost left out was state, New York, because we're all talking about carbon footprints today. What that gives me, notice when I click in here, it gives me all the states. It also gives me an other if you were somewhere else other than in the United States. All right, so number one, we'll say we're in New York, and then we'll come down to the bottom where the tabs are for the worksheets again. And if we come to the last tab where it says Coefficient Table, we come to Coefficient Table, and these are the coefficients, the state electricity coefficients provided to us by the Department of Energy. You can find this out on the web, or maybe you have a better number than we have. Maybe you are in these states, but you have a better number for your area of that state, and you know better what these numbers are. Or maybe you're in Canada, or maybe you're somewhere in Europe, and you need to know better, or you need to go find out. You'll put them in under Other, and you'll just put those numbers in there, and then that way, that will give us our avoidance, our carbon avoidance for the compressed air software. That's where we're getting these numbers from. You know, if you have any questions, of course, contact us, but that's all that is. So it's important, if you're going to use, you know, that avoidance, to choose the right state or to put the right information you have in here. All right? So let's go back to cost. Let's make sure we got everything. We've got New York, year 2009, 15 cents per kilowatt hour. Hours per day, 25, 365. Great. So now we'll go back to our report of June 2009. All right, and we'll look at everything in here and make sure everything's correct. This is the record numbers. The utility is the name of the area or the name of the route that we had made the group. It was in the shop area with the identifier tags. We're looking up air, 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 and air. So if I wanted to change one, let's say we want to change this one to argon, and let's say it's actually emitting at 75 psi there, because that was an argon leak, not an air leak. And here are our decibel readings here. So we have pressure here. Make sure you're getting that correct pressure. Always round down to the lower pressure. The decibel reading will be the exact decibel reading that you collected. And then any descriptions you want to write in. You know, I wrote in found at joint 1, line 5. We could write in this one found at, I don't know, joint 3 on line 2. And so just where is it? And then the next column over, what we want to look at here is CFM column. It's not the actual CFM. What we want to look at is the repaired under CFM there. And it says Y or N. That means yes or no. Has it been repaired? Right now, if it's not repaired, leave it blank. Don't put N in there. Just leave it blank. If it is repaired, put a Y, because that's going to change things for us. Note over here it says repaired $0. So we'll click out of that box. It automatically starts tallying how much we've repaired immediately. And that's just on this one report here. So let's scroll on over here to look at the end of the report. All right, so we have the repaired, yes or no. Work order schedule number. Did you get a work order for this? Who's going to repair it? That's a big part of this. This has to be repaired. Did you repair it while you were out there? Did you carry some common-sized tools with you that you could quickly repair some of these leaks? Or did you have to form a work order to get it repaired? Next column is our cost avoidance column. Notice we've identified $34,497 worth of leaks. Now, I did throw in that big argon leak, but still at the same time, we are leaking a lot out of those 10 leaks, $34,497. That's what we've identified, and only 2 have been repaired. So $1,579 has been repaired. The size of each leak, 3.6 CFM, 2.5 CFM, so on and so forth, all the way down. And then in percentage, how many have been completed? So 5% of what we found has been repaired. And then the energy avoidance in kilowatt hours, so 6,290 kilowatt hours right there on that first leak at 53 decibels at 100 psi. So a lot right there. And then it gives us per leak as well the cost avoidance on the greenhouse gases here. We have carbon dioxide here, 4,967 pounds. Nitrogen oxide, sulfur dioxide, there in pounds. So it gives it per leak, as well as a tally at the top for this survey here. So what I want to do, this is just one survey, just walk you right through it, no big deal, it's just an Excel spreadsheet. I want to go down to the tab on the bottom and go over report. The report tab is what tallies. We saw a screenshot of this earlier in the presentation. This actually gives us a tallied information from all of the surveys we have done. So if I would export another one right now, this would start saying June, what's today's date? June 25th, 2009, and the time is what it would start doing. So you can keep adding on to this over and over again, and it will tally the information. Right now, year to date, it's the same numbers we saw already. $34,497 here, repaired leaks. It's just tallying everything, and then it will list each separate survey as you keep adding to this. So once you export the information, so that's why I made a folder so I could always keep that Excel spreadsheet in there. I'm going to keep exporting to that same file, and it's going to ask me, do I want to replace it? And I'm going to say, yes, I do want to replace it, because it's going to give me the old and the new when I replace it. If I say get rid of it or don't replace it, it's just going to add in a separate Excel spreadsheet, and that's not what we want. We want to keep adding to this one Excel spreadsheet to keep that running tally. All of this is printable and reportable, of course, and it is in Excel, so you can do whatever you want to with it after you've exported it out of here. but we're literally giving you the year-to-date, the exact CFM you're leaking, and that's all converting it to money. So it's really simple. It's really easy to do. And you see, if you scroll across, it gives us all the information tallied up for us. And then, of course, you can add notes on the bottom. Now, if you look at the tabs on the bottom, so the big ones we're working with here, cost, the actual report itself, June 2009 there, report for the overall picture, and to make sure that we have the right coefficients to get that greenhouse gas avoidance. Okay? We do give you a blank master copy if you want to go to File, Save As, and save it as something different. You do have a blank copy that you can manually input information into. And then, of course, a flow rate table if you're using some of the analog instruments or whatever, you can look through here. But again, with the new way we're doing it, all you need to know, all you need to find out is the pressure and the kilowatt hour. Everything else is industry standards as far as brake horsepower and everything like that for the equations to get this information. Okay? All right, so let's get back to, I believe I've covered that all. Let me think real quick here. I don't want to leave you hanging. Just take a look at it. If you have any questions, be sure to call us. We love to talk about this stuff. Yeah, I think that covers it. So we'll get back to the PowerPoint presentation and finish that up, and we'll get that going. So we saw all that. It works really easy. Remember, in a wrap-up of that, we're going to go out, collect the information on our digital instruments. We're going to come back. We're going to download it to the DMS. It's going to populate the information. We're going to export that information into the compressed air survey. We're going to correct our kilowatt hour, our hours of operation, our coefficients, choose the right state or the right numbers if you're not in the states. And then the rest of it does it itself, as long as you've chosen the right pressure and you've taken a good decibel reading. And remember, it's so important to back up 12 to 15 inches before you take that reading. I know it's nice and easy to look at that reading right when you've got that boot sealed up on it and it says 95 decibels, and you back off and it says something like 70 decibels. The better reading is 70 decibels. Don't try to overdo it. It should be backed off 12 to 15 inches. And remember, when you're looking for these air leaks, I see it every time I go train somebody. The guy takes the gun out. We've all done it. Starts scanning, and he never touches that sensitivity dial, and he wants to give up almost immediately because he can't center in on the sounds. Don't think about where the air leak is. Remember, let the sound lead you to where the leak site is, and we do that by adjusting the sensitivity using the gross define method and then putting the rubber boot up on it and confirming the leak with that rubber boot. Okay? So that wraps that part of that up. So visit uesystems.com for other ultrasound opportunities. We do have some hands-on, in-person compressed air inspector courses coming up. August 4th, Milwaukee, Wisconsin. August 6th, St. Louis, Missouri. September 10th in Greensboro, North Carolina. October 6th in Dallas, Texas. October 8th in Irwindale, California. And November 3rd in Toronto, Canada. Remember, these are one-day courses. They're 8-hour courses. Lunches are typically provided. You can see the schedules and exactly where they're going to be held on our website. If you go to uesystems.com, go under training, and then go to schedule, and pick your place and show up. We'd love to have you. But again, that's an instructor in person to do some hands-on with you as well as go through and detail all of everything we've talked about today. Other classes we're having are steam trap inspection, electrical inspection, bearing inspection. Training courses would be compressed air inspector course, the steam trap examiner course, and the level 1 and level 2 certification courses, which are always popular. And of course, those last two, the level 1 and level 2, are week-long courses with the certification at the end of it, as long as you pass everything. All right, and then our next webinar will be July, identifying bearing faults. So please join us. I hope you have enjoyed today. I think we're going to open up for some questions here. I'm not real sure. I believe Alan will be back here in just a second, but I do appreciate you listening in. I hope I didn't go through that too fast for you. If you have any questions, write them in, call us, whatever you can do to get a hold of us, and we'll try to help you out with any information we can. Remember, we love to give you information. We don't try to hide any information from you. We want you to use the equipment. We want you to find those air leaks and stop spending so much money on electricity and emitting so much carbon out there. So enjoyed it. And Alan, are you back with us yet?
Yes, I am. Yes, I am.
Here we
Hi.
go.
How you doing, Mike? Yeah,
Okay.
we've had a few questions. I'm going to, because of the time factor here, be kind of limited, but a lot of the questions were dealing with sensitivity levels versus decibel levels. And in summation, they were asking, if you have a dB reading and you change the sensitivity on the digital instrument, I'm supposing, would this affect the sensitivity, the reading?
No, the sensitivity actually does not affect, as far as on the digital instruments, the reading. Remember, because it may appear that it is, remember that the decibel is what's emitting from that leak. That leak is making that much sound, period. You can't change that sound other than moving, putting your hand over the leak, or somehow physically changing something. That leak is emitting, let's say, 40 decibels. But every time you touch that sensitivity knob, you're moving that gun slightly, that ultraprobe slightly, and it is a very sensitive unit. So it may appear to you that you're changing the decibel, but more than likely you're moving the gun. Test it out. Take it, set it down, keep it as steady as you can, and then adjust the sensitivity. You may even note that it will pick up itself clicking. Every time that little knob clicks, it hears that, but it should go right back down to where it was beforehand. So sensitivity does not affect the decibel, but it will affect whether or not you're going to find it. So remember to adjust it down just to where you can hear it and keep that line of sound.
Mm-hmm. Another common question seems to deal with the pressure and the shape of an orifice. Would that affect the guesstimator chart? Somebody, as an example, said, well, we know that leak shape and pressure differentials will affect the output. But the question is, will that affect our readings and our report?
Well, orifice shape will certainly affect the decibel reading, but in all honesty, it's so minute that it doesn't matter is how we have come up with this estimation of the compressed air chart. Pressure definitely affects how loud something is, as well as orifice shape. But as long as we're getting the decibel reading, because the way the chart was done, the way the readings were taken for CFM was off how loud it was, not what the orifice shape was. It was done with pressures and how loud it was. So while, yes, a very jagged shape might produce a little more sound than a smooth shape, we're still talking about 100 psi leaking out of a hole. So while it does affect it, it's very minute to our estimation.
Yeah, that's, I guess, why we call it the guesstimator chart. And then there was I had a few questions about the pressure. Evidently, people want to know, when we're looking at that pressure on the chart, is that pressure in the system or at the leak site?
Well, the better would be at the leak site, but do you have some kind of pressure drop test there or a gauge right at that leak site? In some cases, yeah, you do. So you take what we want is the closest pressure that you can get at the leak site, that you can actually say, hey, I know it's that pressure. If all you have is 100 psi, sitting by a regulator or a gauge sitting by the compressor and says it's 100 psi putting out, and that's all you've got, that's what you work with. Again, I say estimate down to the lower pressure, to the 75 psi, but what we really want to know is at the leak site to answer that question.
Right, that's good. And one other one was we had a few of these actually. It's kind of interesting that people are wondering if we have the ability to correlate the steam loss in decibels as we do with the gas loss. And from what I am understanding, and you can correct me, Mike, this chart was devised primarily for gases, and really they did not include steam in the development.
That's correct. Steam really does have a different viscosity entirely from air, but there is a steam loss calculation chart on our website, if I'm correct.
That's
if you go to the, it'd probably be under Tech Help, but there is a steam loss calculation chart, and that is different, though. It is very different than what we're doing here.
Oh, great. That's about all we have time for now, and I really want to thank everybody for their patience, for waiting until we were able to get Mike live and get his mute unmuted so he could speak. And really appreciate your attendance here today, and look forward to having you join us at some future webinars, including the next one on identifying bearing faults. Thank you, everybody.
Thank you, everyone.